Today we're going to finish up the machining on the Toolpost. Welcome back to Cloud 42, I'm James. This is the Toolpost dial indicator holder that we started machining last time. And last time we took the aluminum stock, held it by the very bottom edges. I don't know if you can see the little nicks in the side from where the cleats grabbed it. And we machined everything down to a waterline. So the entire part, the outside contour and all the features on the top have been formed. And now we just need to flip it over and remove this material off the back and form a few features on the back side. Now I would normally flip this over and just hold it in the vise. In this case, we've got some nice flat sides on it. It should be no problem hanging onto it. The problem though is that we have a channel milled all the way through the center, and that's going to need some support, because if I just flip this over and squeeze it, we're going to be putting a lot of pressure here and it may distort the part. Now this would be an excellent application for an adjustable parallel if I had one, and if I had one that was small enough to fit in here, but I don't. So what I'm going to do instead is fit a stack of gauge blocks. Now this is aluminum, so I'm not too worried about damaging the gauge blocks, and I'm going to be careful with them. But normally you'd want to use a scratch set, or you'd want to machine something else to fit, or like I said, use an adjustable parallel. The gauge blocks are really a measuring tool, not a fixturing tool, but it's what I have, so it's what I'm going to use today. So this is a stack that I worked up and wrung together that will just fit in that slot firmly, so that when I flip this over, I can squeeze it in the vise. And I've got parallels in here, and I'm just going to set this down in the vise and tighten the vise down on it. Start by snugging that just a bit, and then get a dead blow hammer and make sure that this is seated as I continue tightening. You can kind of hear once it's all the way down, and I can feel that the parallels are tight. And if I look underneath, I can see that my gauge blocks are still in place and they are not going anywhere. So I think we've got that in place well enough. Now, to machine this material off, there's a couple of ways I could do this. I could just come in here with the Superfly and just try to take this off. The problem is there's several places where we've got overhangs, like right here on the corners. We've got the dovetail in here that's going to be exposed when we take this off. And so there's a big flap of unsupported material. And the Superfly carbide insert has very positive geometry on it. And so as we mill down through this and this gets thinner, it's going to get flexible. And as that cutter comes along, it's going to grab it and start to peel it up. And then the next pass of the fly cutter as it comes around is going to slam into it. And you can stop the mill cold, you can break inserts, you can knock things out of alignment, you can actually yank the part clean out of the vise. So I don't want to do that. What I'm going to do instead is I'm going to come down with a 1/4 inch end mill, and I'm just going to contour around the part and cut the top hat off. Now when I milled this was originally an 1.25 inch thick. The part's only 1 1/8 inches, and I've taken 25 thou, so I got to take another 100 thou off of this side. And I actually have a little less than that here, so I can actually go all the way through the top hat, but still not be down to the top surface of what will be the bottom of the part once I fly cut it off. So that's what I'm going to do. The other thing about this operation is, because there are going to be some features on the back, namely there are going to be some counterbores for the screws, and there's going to be a chamfer all the way around, I really need this to be lined up well. But this top hat is preventing me from getting my edge finder down onto the side of the part because it overhangs. So what the plan is I'm going to come down and actually center up on the stock. Since these were rough sawn edges, it's not going to be perfect. It's not going to be exactly the same, because the stock wasn't necessarily even square on the ends. It's not necessarily going to be a correct zero, but it's going to be close enough to take the material off and then deck this down. Then the top hat will be gone, and I can re-zero X and Y before I mill any of the other features on the part that require more precision. So the first thing I'm going to do is just zero up the mill on this as we have it here. Okay, now I've traversed the mill to X0, Y0, and that looks centered. Sometimes I make mistakes and mess this up, and that's always a good sanity check. Now let me run down and set the 0 on top. And there it is. Now that's going to be close enough. The thickness of this part is not critical. What might have been better would be to actually, instead of setting my 0 on the rough surface of the stock, set my 0 on the top height of the parallels, maybe using a 1, 2, 3 block or something to touch off on. It's not going to matter because the thickness of this is not critical at all. And in fact, I was playing around with this on a surface plate, and the back of this part was within a thou of level and within a thou of the correct height anyway, so this is going to be plenty close enough. Okay, I have the G-code loaded here, and the first tool is going to be tool 15, which is the 1/4 inch end mill. Let's get a little coolant and going, and then let's contour this off. Now, as one might have expected, we are close, but not perfect on the alignment, and that is going to be just fine. I will, after this comes off, then we should have the edges exposed and we should be good to go. Next tool is the fly cutter. This thing throws chips everywhere, so I'm going to pull this curtain closed. Very nice. And it looks like we're all the way through. Got a tiny burr on this edge, and I'll just take that off before I do any measuring. There's going to be a chamfer here anyway. It's going to be bigger than what I'm filing now, so I feel no burrs. Let me just make sure. And as you can see, the holes that we drilled through from the other side are exposed now, so I think we're good. And we are going back to tool 15, the 1/4 inch. Actually, before we do this, we need to get an edge finder and re-zero. If we just went ahead and ran this, it would be close, but not perfect. Now we're only going to zero on X and Y. The Z height is still the same, and in fact we've lost the surface that we were referencing the Z height off of anyway. Now we didn't change the Z, we're just going to leave it alone. Now the 1/4 inch end mill. And this tool is just a counter bore for the screw heads. And the last tool here is going to be the chamfer mill, which looks suspiciously like a 90-degree spotting drill. Mostly because it is a 90-degree spotting drill. Don't need the coolant on this, but I'm going to give it a little bit just to lubricate and keep from getting aluminum buildup on the high-speed steel tool. Okay, this turned out pretty much the way I wanted it. The chamfer is nice and even all the way around, which means we got the 0 nice and tight. The only thing is there's no chamfer on these edges right here, and the reason is because I forgot to repost the G-code after we made the adjustments to the dovetail last week. So let me go repost the G-code and just run the contour, run the chamfer just around this edge again. Much nicer. Much happier with that. Okay, well, I think that is all the machining. Now, I think we're ready to take this out. And the gauge blocks fell out of the bottom. Perfect. Well, I am very happy with the way that turned out. Bottom looks great, it's nice and shiny and smooth, get a good finish off of that Superfly. The chamfers look, to me, at least to eye, to be very, very even all the way around, which means we got the 0 just dead on. There's a very, very light chamfer, maybe 5 thou on the inside of these counter bores, which is perfect. A big chamfer would have looked really funny. Chamfers look pretty much the same top and bottom. And by using the technique I used here, where we used the Talon Grips and machine all the way down past the final bottom of the part, there ends up being no seam on the side. Something like this that has a vertical wall all the way top to bottom, if you try to mill from both sides, you're never going to line it up perfectly. There will always be a thou or two that you'll be able to feel. But by using this technique where we mill past the bottom of the part, that doesn't happen at all. And the only place where you'd have a telltale if it didn't line up would be the chamfer around the outside, and that's close enough, you can't see the difference. So this part is all but done. We'll have to put the indicators in it, but we're also going to need a height adjuster to control the height on the lathe. And to do that, we need a piece of threaded rod and a knurled height adjuster. Let's go over to the lathe and make them. Okay, so we've got the indicator holder block done. I'm very happy with how that turned out. As we tested before, the dovetail fits and locks securely, and so we have a good mount on the dovetail. However, we don't have a way to adjust the height. We need a height adjuster, and the height adjuster is going to come in the form of a 3/8 24 screw, and I couldn't find one long enough, so I got a piece of 3/8 24 threaded rod, and then we'll make a little thumb wheel knurled height adjuster disc that'll ride on the top here. So let's start with this rod. I've cut this off. It needs to be just over 2.4 inches long, and this is cut off to about 2.5. So let's just face it down and clean up the ends. And I'll grab this relatively lightly in the 3-jaw chuck so I don't make too big a mess of it. And because of the way the hole is drilled and tapped here, this hole is tapped to the bottom of the physical hole, but I used a taper tap. So there's no, or at least it's not a bottoming tap. So there are not threads all the way to the bottom. So I'm going to go ahead and just take some threads off of the end of this, about 1/4 of an inch, just to make sure we can get this rod to bottom all the way in the bottom of the hole. Okay. See if that threads in properly. Yeah, that's going to be nice. Nice and solid. Okay, let me clean up the other end too. Beautiful. Okay, that's the screw. Next thing we need is the height adjuster. And the height adjuster is going to come out a piece out of 1-inch cold finish steel. Now, if you remember the episode where I finished and did a test grind on the Toolpost grinder, this is actually the piece of steel that I did my test grind on. We're done with that, so it's now going to become a height adjuster. Okay, the height adjuster is going to be 215 thousandths thick, and the outside for knurling needs to be turned to 855. Now we want 215 thousandths, so I'm going to cut this just a little bit long. And let's part it off. Okay, there it is. There it goes. Okay, so we need to flip this around and face this side of the part, and to do that we need to hold it out in the tip of the jaw so we can get at that. To do that we need to hold it parallel. So I've got a lathe spider. This is just a 3/4 inch thick piece of aluminum tooling plate with 3 set screws in it just to offset it from the backing plate. This goes around the jaws. And it's already set up with these screws so that the front is exactly parallel, and I can then clamp a thin part like this. And I don't want to totally mash the knurl, so I just do that lightly. And now I can come in and face the front side. Make sure I'm not going to touch. Yep, I've got clearance. And check it with the screw. And there is our adjustment wheel. That is going to be perfect. Okay, well, let's do some assembly. Going to start by just putting a couple of nuts on the top of here that I can jam together, and then use that to drive this all the way in. Here we go. Adjustment nut first. Then a wavy spring washer and a lock nut. So this will allow me just with thumb pressure to turn that down to a point where this is, I can still turn this, but it's held and there's some resistance so it won't adjust itself. So this goes on, drops down until that hits, and then I can adjust the height by screwing this in and out. Then when I have it where I want it, I can spin this down. And then I have a height adjustment that's repeatable, so I can set this back on here. It ends up at the same height every time. Okay, let's put in some indicators. Okay, so I've got the indicators, no backs on them, just the screw holes. Goes in like that, and then I've got a bunch of these, which are M2 by 0.4 by 10 millimeter long screws. That's one side. Now the other. And there it is. let's throw something in here that we can actually indicate. Now, this is definitely not going to be concentric because I ground it, held in the 3-jaw, and then I've just thrown it back in the 3-jaw, turned to some other position. And so there's definitely going to be a few thou of run out. Let's see. Drop this in the tool post over here. Go ahead and turn the bezel around. Set that to 0 and give it a spin. Oh my, look at that. Yeah, I'm not sure what I was holding this thing in when I ground it, but it's not concentric with the chuck. How about the face? Now this isn't fair because the face isn't even as smooth. But that looks pretty good. Dovetail is just a touch tight, but I think part of that is just because it's freshly cut aluminum against the cast iron. As you can see, as the jaw lifts, it kind of hangs up on the aluminum. The aluminum might not be the best material for this, but this is definitely going to get the job done, and I really like the way that turned out. It really is a beautiful part with the aluminum and the darker screw and the black oxide-coated screws on the bottom. I just really could not be happier. I could make another one out of steel, but I don't think I'm going to bother. I think I'll just live with the aluminum being a little sticky, and because it's aluminum, because it's softer, as I use it more and more, these surfaces are going to smooth out and wear a little bit, and it's going to start to go on. See, it's already going on better than it was the first time I put it on, so I am very happy with that. Well, that is it for this part, or I should say that's almost it for this part. I do want to do some engraving. I want to put a maker's mark on it and a date, but I have some new tools that I want to try out for that, so that's going to be another video. If you are enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.